We can use the product property of square roots and prime factorization to be able to simplify expressions involving square roots. If we're trying to multiply two numbers, 2 square root 2 times 3 square root 50, what we need to remember is we multiply outside to outside and inside to inside. So that means we're going to take the 2 and multiply it to the 3, and then we're going to take the square root of 2 and multiply that times the square root of 50. We can use prime factorization to break down 50 into 5 and 10, and then further break that down, the 10, into 5 and 2. So we end up with 2 times 5 times 5 times 2 under the radical, and we see that we have a pair. We're taking the square root, so we're looking for 2. Every time we have a pair of numbers, so in this case we have 2 5s, that means 5 can come out of the radical. And we also notice that we have a 2 and another 2. That means that the 2's can also come out of the radical. Now, you might have noticed in an earlier step that 2 times 50 would have given us 100, and the square root of 100 we know is 10. So that would have given us a 10 either way. But our 2 times the square root of 2 times 3 times the square root of 50 gives us a final answer of 60. Knowing what we now know, let's try to work on example 1, part A, where we're simplifying the square root of 124. So we know the very first thing we need to do is work on the prime factorization of 124. And 124 is an even number, so we can start with 2, which is a prime factor, and that gives us another factor of 62. 62 is also even, so we can break that into 2, and 62 divided by 2 is 31. 31 happens to be prime, so 124 can be rewritten as 2 squared times 31, and remember we're taking the square root of that. So we look for perfect squares. 2 squared is a perfect square, so that means the 2 comes out of the radical, because what we've really got is the square root of 2 squared times the square root of 31. Square root of 2 squared is 2. Square root of 31 is going to stay the square root of 31, and we've got a final answer for our question. In part B, we are multiplying the square root of 5 times the square root of 18. So let's do the prime factorization of 18 real quick. We know that that can be 2 times 9, and we know 9 is not prime, and that can be broken down or factored into 3 and 3. So we know 18 is 2 times 3 squared. That means what we're simplifying is going to be the square root of 5 times the square root of 2 times 3 squared. And that's going to be square root of 5 times the square root of 2 times the square root of 3 squared. And the square root of 3 squared is 3. The other two are going to stay as they are. So our final result is we're going to have 3 times, and now we combine these two, inside times inside. So 3 times the square root of 5 times 2, which is 10. In example number 2, we've got variables to work with. So once again, we're going to break it into pieces. We know 27, prime factorization of 27 is going to be 3 times 3. So we can write this as 3 times 3 times 3 times a times a times a times a times a, that's 1, 2, 3, 4, 5 a's, times b times c times c. Okay, that's everything that is going to go under our radical. And now what we're doing is we're looking for pairs. And we see that we've got a pair of 3's we've got a pair of A's, we've got another pair of A's, and we've also got a pair of C's. So all of those are going to be able to come out from under the radical. So there's our 3 and our A and our other A and our C. So those come out, and whatever stayed underneath the radical, whatever we don't have highlighted, is going to stay under the radical. So those are all going to come under the radical 3 times A times B. That means that our final answer is going to be 3A squared C times the square root of 3AB. And that is our final answer. About 6 minutes on the product property of square roots.